So Gyres is conducting a study of PHA. PHA stands for polyhydroxyalkanoate. It's made from off-gassing of microbes. They make PHA. We can extract it and make a plastic. Now, these are things that consumers are getting. We want to understand if they get lost in the environment. If this bottle gets lost on the beach or on the side of the road, in those two environments, terrestrial and aquatic, what happens to them? Do they degrade very quickly? How long does it take? Do they degrade completely? These are unknowns. We're going to put these in the marine environment here in California, right here in the bay. We're going to also put a set of this stuff in my backyard in the California desert. And we're also going to do this in the aquatic environment and terrestrial forest in Maine and in Florida. So 6 environments over 64 weeks. So we're really going to understand, how does PHA degrade over time in different environments? So 2 weeks in the ocean, we'll take it out and study it. Another set, that's 4 weeks. And then 8 weeks, 16, 32, 64, so a year and a half, that's our study.
There are a lot of public misunderstandings about PLA, polylactic acid. That's your typical, eco-friendly cup you might see at environmental events and so forth. While the fine print says that they degrade only in an industrial composting facility, not your backyard compost, the public didn't know any better. And there wasn't a big media push, communication strategy to upend that myth, that misconception. So it's kind of pervasive across the country, people putting their PLA products with green waste and food waste, to the point that, like for example, the state of Oregon, all the industrial compost facilities said, no more PLA. It actually doesn't break down in the composting setting very well at all. People were finding, whole forks and knives of PLA in their backyard compost. This was not a truth in advertising. So the purpose of this study, part of it, is to provide the truth so that people can make good decisions about their purchasing, and companies that want to use PHA can make some good decisions about how they want to use PHA and how they communicate about PHA to their customers.
Still see the straw.
As a consumer, we often have had the responsibility put on us to make change. And I think that we really need to flip that narrative and look upstream and look at the companies producing a lot of the single-use plastics that we use every day.
We are here in California at the terrestrial site for our PHA study.
Our last set of terrestrial samples are here somewhere. So in this area, we buried all 6 sets, and the previous 5 we recovered. But between the 5th and 6th sample, we had like torrential downpours of rain and a lot of sediment. So this whole area was covered about a foot thick layer of sand. So I got a tractor, go dig in here and try and find them. I mean, the materials behave differently in different places. Here's a straw. It's unchanged pretty much a year and a half later. So this environment, of course, is affected by some moisture, but I'd say by and large, there are very few microbes living in this dry climate to break down things, unlike the swamp environment in Florida where other samples are located. So temperature and humidity really matter.
Even though it was really dry and buried, you still see this fragmentation.
The 9-month mark, our halfway point, some of the ocean samples, almost half the stuff was gone. All the utensils in the ocean were falling apart. You can see here, it's as if you just put it in the ground. No change at all. It's beginning to fall apart. It's fragmenting a little bit. The neck of the bottle's fallen off. It feels very brittle. I could feel a crack in my hands when I gave it a little squeeze. It's in terrestrial setting, again, really, really slow. For all these samples now, we're gonna box these up and bring these to our lab in Florida, where our colleague is gonna shake out the dust on every sample. If they're fragmented, pick up all the fragments and get a good dry weight.
Took a good while to set all this up. It's 2,376 samples total, and each bag is tagged. He rinses it. We have a desiccator over there that will allow them to dry. Once they're sufficiently dry, then he gets the weights, and then I photograph them, and then they are archived. And this is the kind of thing that we're seeing.
Florida versus Maine here.
Versus Maine.
Wow.
Yeah. This was a strip off of a PHA bag. This is at the 8-week time interval for Florida. This is at the 16-week time interval for California. So it's a remarkable difference. My water temp here, it's been in the low 80s or above the entire time. It's a big difference.
What were the results of this study? We were measuring fragmentation, how an object, like a bottle or a bag or a straw, fall apart into smaller pieces. That was our study. We found some amazing things. One, the environment matters. Things in the marine setting in Florida, they fragment much quicker than the dry deserts of California. What this study told us is that it's not just the material that matters, also the design of the product you're introducing to the market. For example, a toothbrush handle is going to fragment very slowly. There's not as much surface area available to microbes as there might be for a piece of thin film. Let's say a potato chip bag or a candy wrapper is going to fragment much quicker than a thick object like a fork handle. What are our thoughts on labeling things as marine degradable, biodegradable, or compostable? What does it mean as a standard for marine biodegradation? Typically, that standard and measure is in a very specific laboratory environment, recreating an ocean setting. Well, that doesn't represent every place that trash could go. What we did in our study, we looked at 6 different environments, and we found that those measures of fragmentation, they really vary from place to place. A measure of marine degradability really should be in a more realistic setting. Based on this study, we realized that there are new materials that can make packaging have less of an impact if it's lost to the environment. We'll have to consider some kinds of packaging are perhaps better suited to a single-use material, and we think thin films are more appropriate for that use. So they fragment very quickly in different settings. And that's going to allow it to be a useful material in the packaging revolution.